Hi everyone, this is Merrick, the chemistry guru. Now in this week's video, we want to learn how to calculate the Kb of conjugate base from ionic product of water. So let's take a look at this question. The acid dissociation constant for the diprotic acid, malonic acid, H2C3H2O4 are Ka1 and Ka2. So the values are given accordingly. Question is asking for Kb for HC3H2O4 minus the base dissociation constant for HC3H2O4 minus. And we have four options, A, B, C, D. We want to decide which is the correct answer. Now the topic tested in this question will be under ionic equilibria. And let's first consider the dissociation of my diprotic acid. Now remember, involving a diprotic acid that is capable of dissociating and releasing two H pluses or two protons, but a diprotic acid will not release both H plus in one shot or in a single step. It will be broken down into two subsequent steps, and in each step there will only be a dissociation of one proton. So the dissociation will look something like this. My H2C3H2O4 will dissociate to give me one proton to form conjugate base HC3H2O4 minus. So this is the first dissociation. You notice the dissociation, the mole ratio is 1:1:1. That means your diprotic acid will dissociate its first proton, and the acidity of your H2C3H2O4 is being quantified or is being described by Ka1, has a Ka1 value. Then your HC3H2O4 minus, because it can dissociate a second time, there's another proton that it can dissociate. So we will talk about the second dissociation, which is involving dissociation number 2, HC3H2O4 minus, dissociate to give me one more proton to form C3H2O4 2 minus. Turn by turn, one by one, involving the dissociation, involving a proton, I dissociate to give me one H plus, then followed by a second H plus. Now the second equation is describing the acidity of HC3H2O4 minus. Therefore, we will have this Ka2 that quantifies the acidity of your second acid, HC3H2O4 minus. So now that we have written down these two dissociations, the next thing we want to do is we want to determine how do I find Kb for HC3H2O4 minus. You notice this HC3H2O4 minus is actually here, involving this blue guy that I've highlighted. So maybe if we do by color coding, it is easier for us to reference the first acid. Your malonic acid is the yellow species, H2C3H2O4. Once it dissociates to give me one proton, its conjugate base is HC3H2O4 minus. And in this case, since we are interested in the Kb for your HC3H2O4 minus, then I'm interested in dissociation number 1. But let us talk about the formula that we should be using. How do I determine Kb given Ka expression? The formula that we have is Kw, which is ionic product of water, is actually equals to Ka times Kb. But very important for us to keep in mind, Kw is equals to Ka times Kb is only applicable for conjugate acid-base pair. Conjugate acid-base pair is where the difference between the acid and the base partner, it is a proton. So only when the difference between your acid and the base is a H+, they will be counted as a conjugate acid-base pair. Then the Ka of the acid multiplied by the Kb of its conjugate base will be equal to Kw, that is the ionic product of water. We have listed down the examples here, involving Ka of H2C3H2O4 multiplied by Kb of its conjugate base, HC3H2O4 minus. This is equals to Kw. Then if I consider the second dissociation, involving your Ka of HC3H2O4 minus, which is here, multiplied by the Kb of its conjugate base, C3H2O4 2 minus, which is here, is equal to Kw. These two expressions are valid, and again, we just want to reinforce and keep in mind your Kw is equals to Ka times Kb. It is only applicable to conjugate acid-base pair. So you cannot use the Ka of any acid, and you go and multiply by the Kb of any base, and we say that it is equal to Kw. The idea is not valid. The question is asking me to solve for the Kb of HC3H2O4 minus, basically the blue species that we've highlighted. So what we will do is we will actually focus on this first equation here. Ka of the yellow guy multiplied by Kb of the blue guy, which is what we want to determine, is equal to Kw. So I just need to rearrange this my Kb will be Kw divided by Ka of H2C3H2O4, and the Ka value that we should be using is Ka1 because H2C3H2O4 is actually my first acid, and the dissociation of the first acid, the acid dissociation constant that quantifies the first dissociation is actually Ka1. I should be using Ka1 instead of Ka2. So the answer to this question involving Kb of HC3H2O4 minus will be Kw divided by Ka1. So answer will be option C. Alright, so that was the discussion involving calculating Kb from ionic product of water. So if you have learned something useful from this video, please give me the thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. I'll see you next week.